Right? But I thought maybe we would do it together. Right? We'll do it together this time. And in fact, the one I want to do is this. Right? No new topics. Okay, we'll wait. We'll time you. We'll time you. And we're not going to do Fibonacci. I don't want to do Fibonacci. We're going to do this one. We're going to do numerical differentiation and integration. Because this gets used a little bit of this. To do this, we got to do a loop, right? We have to create our own function and then some stuff like that. So we're just going to go through these things. How you doing? You missed all sorts of important stuff. Like why I'm the Eagles fan. Like why I'm an Eagles fan.
Like the homework's not due till next week.
Well, just kidding. Yeah, but nobody's gonna work on it anyway. Were you gonna work on it?
I already started.
Oh, you did.
I would have worked.
Oh yeah, Bryce came to me earlier. He's like, "Oh, I barely got that homework done. I just put it in ChatGPT." I was like, "Well, don't tell me that you did that. Like, you're also defeating the purpose. Of course, you can put every one of these in ChatGPT. I want you to do it yourself."
But you guys are turning in late. Well,
Yeah.
you know who's done that? Because that's going to be the deviator on the test score.
That's exactly right. I'm gonna find you.
I have a question about the exams. So, like, when you do this, there's a lot of trial and error. How does that work on the exam?
You know, what I did last time, no, it was like some multiple choice, little snippets of code. Like, what does this do? 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 Right? But then there was some thing, and there's some true falses along the way. And then there was some open-ended questions, like put together some pseudocode on how to do this, right? And there is a little bit of, obviously you can't do the trial and error, but I won't grade you based on syntax, right? Like, oh, look, you thought you had it, but you didn't put a dot before this times, and so I'm gonna give you no credit. It's just pseudocode, like logically, how would you step through this? Yep, I'm fair with it. Yeah, okay. So, no, he's just jumping ahead.
Don't look at the syllabus. It's not on there.
Right.
Yeah, I leave it wide open syllabus. Okay, we did just talk shit about you, Bryce, about how you did your homework with ChatGPT.
Yep.
And yep.
You
Okay.
actually did it.
Well, clearly I told you from the beginning you can just put the whole thing in and you don't even have to type anything. Just give it the PDF and say, do this for me.
There's one part I couldn't answer, and I actually put like, I didn't do this right, and I didn't just want to copy and paste ChatGPT code that I don't understand.
Oh, you
And
wrote
I
that. in the
didn't
thing.
do. Yeah, I put percent, and I
Hey,
wrote
you
my
had- okay.
paragraph too.
A, F.
All right. I mean, well, so I was doing it.
Immediately.
But then you can ask for ChatGPT to help you, and then you learn from it, and then implement it. I will say I put exam one into ChatGPT, and I said, "Can you do this?" And ChatGPT got an 86, and there was like even an open-ended questions and stuff. And then the only thing it had with issues, it couldn't read the figures. Some of them had figures, and it didn't know how to read figures at the time, so it couldn't interpolate and stuff. But other than that, it did pretty good, 86. That was higher than the class average. But it was curious because it goes through and it just answers every problem. Anyways, let's do this together. Okay, you open up your stuff and then we'll crank it out at the same time.
.m or .mlx?
Whatever you want. I'm going to do .mlx for mine. Okay, and so I'm going to put my functions down at the bottom. So we're going to develop a MATLAB program to take the numerical derivative of a given function. The program should take as input vectors x and y, which represent the function y is equal to f of x, and output a numerical approximation to the derivative. Okay, so we're going to create a function to do this. Okay, so I'm going to create a new .mlx, new live script. Okay, and then I'm going to create, so you got to do an x equal to something. And so we're going to have it maybe go 0. We're going to have it a space of, I'm going to call this maybe dt is equal to 0.01, and then dt, and then we'll go to like 10 seconds. Okay? See, that way I could change dt, because later on I read ahead and it said we want to change dt at some point. So I'm going to say dt with that, I'm going to x is equal to this, and then I'm going to make this a function of x. Let's just do x to the second. Right. Right. So y is equal to, y is equal, or x is equal to 0 to 10, and then y is equal to x squared. Is that one not working there? What'd you do to it, Noah? Oop. On. On. Off.
I think it's just changing.
On.
Yeah, it's just changing.
Oh, that's
Oh,
that one.
there's that one.
Nope, that one.
Yeah, there.
One more.
Got you guys. You're 5. Your screen 7 over there. I don't know. You go sit with MTS if you want to.
I can see fine. I got my glasses.
Oh, you do good. Good. Okay, so that's it. Y equals X equals that. So right, to do numerical integration, everything has to be like defined, right? So X is defined. So this is, I mean, if you looked at what X, if you wanted to see what X is and you want to look what Y is, right? You could type them out and there they are, right? So they're just little vectors that are changing as we go along. Okay. So then we're gonna make a new function. So we go down here. Okay, we're gonna say function. Right? And then we're going to have a thing. We're going to have a numerical derivative, right? And so call this dv maybe, right? That's what it's going to return as the derivative, right? And that's equal. And you can spell it out if you want instead of just doing short variables. I always just do short variables because I'm lazy when I'm typing. And then we'll say my derivative, my dv, yeah, my dv. Okay. I don't want to spell it. Yeah, and then we call that. And we have to give it to it X and Y. I could call this any variable I want, right? Outside they could be, one of them could be T and one of them could be F if you want. It doesn't matter, but just inside this function, I'm gonna have it be X and Y. So they're gonna read in X and Y, okay? And then we'll end that function. So then just to show you, right? Let's say our function is just gonna display that X. And so I'm gonna come in, I'm just gonna say my dv, and I'm gonna give it X and Y. And then when I run this, it should display what X and Y are, just to show you that, it's case sensitive. Right? And so the only thing I'm doing inside of this function, right, is displaying X. So right now it's just gonna display X, right? Okay. But so then we want to do more than that. We want to take the derivative of something. What is the definition of a derivative? Use the slope, right? But then like if you go all the way back to like what the definition of derivative is. MTS, you're almost a doctor. What do we got here? You shaved MTS. Yeah. Yeah. What's the original definition? Way back when?
It's like the limit as x goes to infinity, or it's a limit function.
Yeah. It's
It's a rate of change.
Yeah. I even told you before.
You told us to forget calc.
Oh yeah, okay, yeah. Right? It's the change in y. It's the rise over run. So back to your thing, right? It's the rise over run, right? And that's what slope is, right? The rise would be, f of x plus 1 minus f of x divided by
dt.
the change, dt, with the change in it, right? So that's what we'll do, is we'll need to go through and we need to look at the difference between all of my y's and divide by the difference in all of my x's, right? That's what we have to do. So
it's just y of x plus 1 minus y of x
yeah.
divided by dt.
Yes. So you can go, so it'd be a for loop, right? Because you got to loop through these things. For I equals 1 to length of x, right? So this will step through every element that we have in x. We're gonna have an error in a second, but we'll deal with that in a second, okay? And so I want to take the change in y, right? So my y is just a vector. So y of I plus 1 minus y of I. All right? My next value minus the value I'm at, right? Next value minus the value I'm at, that's my change in y, and I have to divide that, right? So I put these in, we gotta be careful about orders of operation, but we'll divide that by x of I plus 1 minus x of I. Okay, but again, orders of operation, we gotta be really careful. I gotta put parentheses there, and a parentheses there.
Just use dt as our.
You absolutely can. I was gonna get to that in a second.
Sorry.
B-dog. But if for some reason I didn't have, like if these weren't linearly spaced, then it wouldn't work. Yeah, but you're absolutely right. Okay, so this is, right, so this is my change in y or my change. Remember, you've read f of x plus delta x minus f of x divided by delta x as delta x goes to 0. And that's the definition of a derivative originally, right, was that. And so this is just an approximation, right? If my dt is not really small, this approximation gets worse, right? But that would give me the thing. And so this would be dv, right? I could call it just dv. If I called it just dv, then every time dv would be replaced. It would just be storing a scalar. So I want to catch each one of these things. And how I catch each one is I do that, right? So I catch dv of I. So in the ith place, it does that. Right? So let's just step through what is going on, right? It's starting out, and it says, all right, I'm going to do a for loop. I'm going to loop through every element in x. And then I'm going to say, hey, what's the differences in y's? I'm going to divide that by my differences of x, and I'm going to store that in dv sub I. Then I'm going to change I to 2, and then it goes to 2, and it does this. It does it for 2, and then 3, and then 4, and then 5, and then 6, and then 7, and 8, and 9, 10. Okay? This will have an error. Can anybody see what the error is going to be if I try to run this code? What the problem is going to be? Oh, I don't have I'm missing an end. Okay, that's not what I was after. Let me finish.
DV doesn't have a starting line?
No, it's okay. DV will grow. DV will be fine. Usually you would start out with a DV, but you're right. You're kind of right. What's the problem here? Think about the limit.
There's no boundary.
No, the function's already defined. It's a coding problem. What's that?
Does x need to have a dot after it?
Nope.
It's an indexing problem. It's where we start our y plus one.
Kind of.
Y plus one.
Yeah, that's right. See, think about this. So say we're going however long x is, okay? Y is the same length, right? So say x is 100 elements long, right? And I go through and it says, all right, I'm going to start out I plus 1. See, so this is, so if x is 100, if I get to the very end, it comes down and says, I want to check y of 101. I want the 101th element in y, and it doesn't exist. My I goes too much. I've gone too far. I can't go all the way to the length of x. I have to go just a little bit before the length of x because I'm trying to look at this. So let's just see. Let's see what the error gives us. Run it and see what it says. Oops. Yep. Yeah, see, this is what happens. If you don't put a dot, it shows you dv getting bigger and bigger and bigger and bigger and bigger and bigger and bigger, but you don't want that. So I need to put a semicolon after it, and it'll make it run faster. And he said index exceeds number of array elements, right? That's what it's telling us. See, I told us exactly what the problem was. It said, hey, dummy, right? You've gone too far. Because we try doing, right, for x equals 100, or sorry, when I equals 100, it tries going y of 101. And it doesn't know what to do with y of 101. Nothing exists, and so it can't do it. Does everybody see that? Gavin?
Wait, 101 or 1,000?
Or whatever, however long it is. It just goes one beyond what we have the elements for.
So we just need length of x minus 1.
Let's see. Yeah, exactly. So let me just see. What's the length of x?
1,001.
Oops. It can't get there. All right, hold on. Yeah, it's 1,001. So it tries to go to 1,002, and at 1,002, it tries to index y of 1,002, and y of 1,002 doesn't exist. So the quick little fix right there is instead of going through the length of x, we go to length of x minus 1. So they don't go all the way there, go one short. And then that should do it. That should back us off of there. Okay? Okay, so then you're like, okay, great, dv is defined, right? But then if you come outside, this is what I tried to say before. If I come outside of here, oh, I like it better like this. If I come outside and if I say what's dv, right? I just defined dv down in that function right there. So if I say what's dv, it should give me an error and say I don't know what dv is. But you're like, I just defined what dv is. Right down here I said right, dv of I is equal to this. It's because that dv variable only exists inside that function. It exists locally inside of my dv function, but it does not exist outside of it. There's ways you can make it exist in both places. You have to you call it global. You say global, and it makes it global. It makes it available everywhere, but don't ever do that. Okay. So in this case, it doesn't do that. So I have to catch it. Okay. And so over here, I can call it whatever I want. I call this my derivative. I made a new variable just to show you that it works. Because now, right, this function gets called and it returns dv. So on the outside, I have to catch it. And so I caught it in a new variable I called my derivative. You can call it whatever you want. So then now, right, my derivative is caught, and now my derivative is the derivative of it. Okay? So now, like, just to show that it works, we should be able to plot it, right? Let me plot x and my derivative. This isn't going to work. This isn't going to work. It's going to be an error. What's the problem? Huh? Yeah, why are they different?
They're all set by
Because they're all set by 1. Which one's longer?
X.
X.
'cause it starts at
X.
0.
Yeah, that's right. And it makes sense that this would happen, right? Because I'm looking at the differences. I'm looking at the difference between y's and x's. So I'm looking at the differences. So it's going to shrink by 1, right? Because if my derivative is the differences between each element, right? If my derivative is the differences between every element, you're going to lose an element. You have to look at what's this one and what's that one. So they're 2 different lengths. So then I gotta plot them. And so there's a couple ways to do it. You go like this: 1 to end minus 1. That's an advanced maneuver. Did that not work? Oh, nope, just n minus 1. And 1 through n minus 1. If I should variable, because otherwise check. Oh, I put it in the wrong place. What am I fucking doing? Okay, wrong place. That's stupid. Up here, I was trying to do that. 1 through and minus 1. That works. I'll tell you what I did there in a second. Right, just to show you that it worked. Right, so the red right here is x squared, right? And what's the derivative of x squared?
X over 2. No, X 2x.
Thank you.
2x. You 2.
2x. I know, you immediately purged that. My son's in calculus right now,
Can
so
you
I...
scroll up on your code?
No. Yes, I will. Right? So the derivative is 2x, right? Right? X squared, the derivative is 2x. And then does this look right? I would say the blue, right? The blue is right. It's just a linear, and you can confirm that it's equal to 2x. Did I ever actually calculate that? No. This is the numerical derivative, which is really cool that you could do this, right? That numerical solutions to stuff is so cool. I don't need to know what the rules are for taking derivatives of things, right? I don't have to know what those rules are. I just could do it brute force. I just say, well, I know that the derivative is the change in y over the change in x. Let me just do that at every single location, and then it'll just work, right? And I don't ever actually need to know that there's a rule that you take the exponent, you bring it down, you put it in front, and then you lower the one up at the top. You don't program that in. It's just based off of just the brute force method. You can calculate the derivative of these things. Taking numerical derivative. So just a little side note, there's a command called diff. Diff returns to you the differences between an element and a vector. So that's all we did. We programmed diff, right? It takes this over that. And so you could do it that way. Cool, so we did the first part. Any questions about that? Did everybody tracking? Gavin? For now, right? It's been cool. I think that taking numerical derivatives up is fucking sick. You just need to do y and x, and then you can calculate this stuff. Okay? You calculate the derivatives of things. You could do any function, right? You come back up here, call this x cubed, right? What did it do? What's it doing? Crapping out on me. It's doing something. Right, so there's the derivative of x cubed. Okay, but it'll work for any function, which is kind of neat. Okay, so then what's the second part say? Do numerical integration, is that what it is? What's happened to my plots? Oh, there it is. See, as I say before, like, if you do .ems, it's really good. It doesn't do weird stuff like this. It's not even doing anything. It's just it's holding that thing. It's not really plotting what I asked. It's all grayed out. So sometimes if you're getting heavy and doing big calculations, you should do it in a .m. Should I pause here for a second? Has everybody got this? No comment? Ciara, you got this? Connor almost called you Cooper. It's Cooper DeJean, dude. That pick 6 yesterday by him, huh? Huh?
On his birthday.
On his birthday.
On his 22nd birthday.
On his
He's younger
22nd
than
birthday.
me.
I know.
That's insane.
That's insane. We good?
Are we supposed to be working on Heartbeat?
No. But you're tracking with this and everything. You're tracking with this, Joseph.
First half was.
Oh,
Their defense
I know.
was crazy.
So cool.
It was kind of boring.
You shut your mouth.
It was good. It was like, there wasn't a fight.
Yeah, I know. I just loved watching Mahomes. I loved watching Mahomes just get abused.
His offensive line
Oh.
did not have it.
How about when he got hit in the face on that fumble and he fucking got flattened? Yeah, fuck yeah, dude. That's for all the flops he did. All the flops he did earlier on.
It wasn't enough.
Yeah.
It wasn't.
Yeah.
Either first half. 22nd or 22 and 14. It's fun to win.
Yeah. Right. I was worried after that first offensive pass interference. I was like, oh God, here we go
And
again.
then they got like 9 calls against him.
Yeah. All right. Let's do the second part. Develop a MATLAB program to numerically integrate a given function using the trapezoidal rule. The program should take as input the vectors x and y, which represent the function that y is equals x, and then output the numerical integration of the integral, or the numerical approximation of the integral. Okay?
Using the same methods.
Same methods, right? There's a trapezoidal rule. So the integral is going to be the area underneath it, right? So then how would I calculate this area underneath this curve?
Oh, yeah.
Yeah.
By like breaking it up.
Yeah, right? So you do the trapezoidal rule, right? I could go
Oh, you have a little figure.
little diagram. Yeah, right? So I could say, well, the evaluate this x right here, and then I multiply it by the difference between that one and that one.
Finding which chunks of various
Yeah. You do it along the way. You say, all right, my f of x plus 1 minus my f of x, that difference multiplied by my dx
Yep.
divided by 2 gives me that area, then that one plus the thing, right? You could do that. Right? Or
I'm gonna.
There is a trapezoid.
there is a trapezoid.
Equation.
Yeah, there's an equation for the area of a trapezoid. But if it's oblong like this, I don't think you.
Yeah.
Or it's the average of these. It's the average of these multiplied by it's the average of them. You take the average of the two. You take the average of this one, and then you multiply that by the dt. That's what you do. It's this height.
It's different sum, but yeah.
Yeah. So let's do that.
Oh, I can't
Yeah.
wait for Wednesday when Connor brings in treats.
Here we got Connor.
I gotta get a recipe from my mom.
Oh, you're doing it. You're doing like a real making.
And it's gonna be my first attempt, so.
Oh, yeah.
What are we thinking here?
Guinea pig.
Surprise.
Oh.
I'm not saying anything.
So if it doesn't work out, you can just buy cookies and that's a surprise.
Yeah.
If it doesn't work out, I can buy cookies and bring it, and then I can have the failure for myself.
Intake.
Yeah.
But only if it's video.
And good thing I don't have anything to do tomorrow besides just
Practice bacon. Maybe you can.
and starting my truck.
Maybe you can have your mom make them and mail them to you. Where she live? Oh yeah, it'd be here express mail it. Say, Mom, I need these treats. I'm pretty sure my wife would do that. I'm pretty sure she would. If my kid said that, I think she would do it. I think she'd make it up, go to the send it. Okay, so here we are. We're gonna do the same thing. 4i equals To be honest, I don't know how to do this, so we're gonna probably gonna have an issue with the length again, but we'll see. There we go. I'm gonna say AVG. I'm gonna say my average height is gonna be my my y of I plus 1 plus my y of I divided by 2 divided by 2.
Capture that.
Hmm?
Did you capture it ahead of the function? Right, you were talking about we have to capture.
Oh yeah, not yet. Not yet. I'm doing an intermediate calc. So I'm just saying I'm calculating what the average height is, right? It's gonna be y of I plus 1 plus y of I, and that quantity divided by 2. So that would be, so if we go back to this figure, that would be this average height. It's halfway between these two. It'd be this height. And I think if I take this height and I multiply by the dt, it's the same as if I did it the other thing. You agree with that? Close enough at least, right? This is an approximation, right? You agree, right? And then that times delta x, right? So then I do an average, and then I'm gonna come down here and I say my integ of I, catching it, like you said, Connor, is equal to my average times my dt, but I don't know, we'll set it up to be,
Should that be there t in egg? Or is this a new variable?
hold on. I 1 minus x of I. Okay, say again there.
That's that same line of code. Is that the integ?
Oh, yep. I wasn't done yet. I was just gonna say, what's wrong with this? And it's because I need a T right there. Yep. That should work, except for, again, the size length, they're gonna be different.
Don't forget your extra n.
Oh, and then I end my function. So then use my same x's. I'm gonna go back to x squared.
Above the original plots. Yeah.
I'm gonna plot, I'm gonna do 2x. And then I'm gonna say down here, I'm gonna say my trap integral is equal to, what did I call it? My integ. My integ. My integ x comma y. See if it works. It works. And then these aren't going to work because that ain't going to work because one's too long. See, you're making me angry. Where did the figure go? There it is. Oh, no, something's not right. Something's not right. Something's not right. Something's not right. Because it should be. Yeah, no, I got it. I know it's wrong. Kind of.
I think it's a straight line.
It's a straight line. It shouldn't be a straight line. The integral should be.
The derivative also reveals.
Nope, it's perfect. X comma y. Why is it doing this to me? Plot that. Plot it.
Hey, yo.
Why isn't it plotting anything? Oh, there it is. Yeah, see, it's not working, right? It should be x squared is what it should be doing, right? It's not doing that. And here's the deal. It's not. Function is this. Yeah, I did. Yeah, I did x for the above. No, I changed it to 2x. I made it 2x. I'm trying to think here. There we go. I did the average of this height. I tried to do I did this. What I did this. Ethan, I said I averaged this one and this one. Right? I averaged this with this one, and then I took that average height and I multiplied it by that distance. But is what I'm, yep, so that kind of gets it. I think what I'm missing is the cumulative summation, right? It grows. It isn't just that. It gets bigger as it goes. Y of I plus 1 plus y of I divided by 2. That's the average height. I'm taking that. This is what happened last time too. When I don't know how to do it myself. What's that?
The summation term.
Yeah, does it have to add them up? I'm gonna do this. I feel like that should have worked.
No, you're missing a whole chunk of this business.
What?
You're taking just the triangle.
No, what I did is this.
Oh, I see.
Yeah, I did the average height between this number and this one, and then I just multiplied it by that. It's janky, is that what he said?
That's janky.
I think that works, but there's something else there's something else.
It's janky. It's janky, let me tell you. What was the bottom half of your code?
The inside port
Yeah.
equals average multiplied by parentheses x. It's just the same thing.
Is it because it's supposed to grow? Is the total area? Any comments? Anybody ChatGPT help us out here? Is it not? Am I supposed to add them to the last one? No, it did. That's right there. There's the average.
So my plot
Love that.
Yeah, you got to sum them.
Yeah, under the if sums.
Yeah. That is your dt, and you multiply it by the average of those two. That's the average of those two.
Why are you giving me?
2x.
Going x squared, right?
Should give me x squared is what the answer should be. We want to look at my code here.
Yeah. Y I plus 1 plus y I integral of I through that period. Okay, mine works.
Do yours does the x squared? Yours works.
So my function's a little different than yours, but let me break it down back to x squared, or to, you have it as x as your function?
My dt not. Yours it gives you the x squared.
Never mind. There's something. Oh, duh. We have it. We're missing the area behind it. It's only doing the area under that specific point. We need to add integ to itself.
It has to keep going.
It has to
You
add
get-
it to
that's what I thought. That's what I thought. I was missing a summation.
You just add integ of I,
I.
right? Because then it's going to start adding to itself, and it's going to exponentially grow, and then but how do we index that?
Integ.
We need to initialize integ outside of the for loop to some value. Integ equals 0.
Yeah, I hear you. I hear you.
Then we run it. Must not
Yeah, you got it. You're gonna have a problem with that too. You're gonna.
but you understand what I'm saying?
Yeah, I got it. I got it. Nope, I don't got it.
And then our plot might have to be minus
Yep.
2.
Trap. Yeah, because you got to add them up as it goes. So 1001.
So it's not, it's just n, not n minus 1. Yep, there you go. It's just n, 1 to n, or x is.
Give me the answer. Quit not plotting things.
Yeah.
First try. First try.
That's
First try. Don't lose confidence in me. First try. By the way, this is coding, right? Like, this is coding, right? You get into it.
We were just plotting the
Yep.
one little
Yep.
chunk of
That's
the
what I
data.
said. I think we're missing a summation, right? We're missing a summation as it's going because it's what I was doing was I was just calculating. I was just calculating this one, but you have to calculate all of them as you go along. You have to you calculate one and then the next one and the next one and the next one. That's the summation, cumulative summation. MATLAB has a command for cumulative summation, but it is not. I don't like it. It's yes. Yes, I can.
Whoa.
The code for the function.
That's goofy, silly, quirky.
So I just added this. It's saying take the previous one and add on to it.
Yep.
Right? And this one makes sense that it actually grows a little bit. You don't lose an element for this one. Everybody okay with this?
So what did you do above?
Yeah, what did you do in the plot?
Yep.
Plot?
So I called out my integration of x and y, then I call that trap int, and then I plot x and trap int. Because they're the same length this time. They end up being the same length. Yeah, good job. Good job. And so that's again, you don't need to know the rules of integration, right? You don't need to know the rules of integration because just doing it brute force method works.
Wait, so you didn't do for the I equals, you didn't have a minus one.
You do for
Yeah, you don't need it because they end up being the same length when you do this one.
Because I'm getting an error.
Your plot is n minus 1 still?
Your plot might be n minus one.
No, my plot is x comma trapping.
Okay.
And my code looks.
You have it going 1 to the length of x minus 1.
Your intake needs to be intake I plus 1.
Oh, okay.
Yeah, I did change that. I caught the next one just like it.
Right, because otherwise it's like it's error because it's saying this is itself plus something else, but it's also only itself. So now you're changing this. There you go.
Cool. Ethan, you doing okay? You got this? You
I never did, too. I know.
for yours?
Yeah.
What's it doing?
Yeah, I had this as just one, so I did I plus one. That fixed mine, but it depends
Oh
on
yeah,
what
you have to
in your
initialize.
plot. What do you have?
Oh, it's gonna be that.
I just said do x comma.
It's outside of it right now. So no, put it inside. Put it
You
one
need
more
to-
line inside the function.
You guys are the same size.
That's messed up.
You alright? You get it?
All four of these intags are the same.
But then we put it into the function.
What about your figure slash class?
Oh wait, no, that's not. Because you end up being the same length.
Okay, never mind. I think you got it. I think it's just confusing. This one is figure two.
One of the problems is you got, for example, J and put a J plus one this one right there.
Oh, I plus one, yeah, yeah.
And the problem was they were both of J, and so it was trying to like, it was trying to call on it and then the exact same spot call on. It was just messing up, and so it wasn't growing. So it wasn't ever getting any bigger. Yep. And so then making the J plus one is making it grow. That should just yep. Everybody get it? You get it there?
Is it supposed to be?
Yeah. So
That second one is?
2x is what my function is, and then the integral of it should be x squared.
Yeah, but for mine, it's like showing that.
Oh. What? No, what's your function? X squared. Your function's x squared.
So now it's going to x cubed.
So it's x cubed. One of them's x cubed and one's x squared. So make that 2x. Make that 2x, and then you'll have one straight and one,
Yeah.
or x or something like that, and then that should do it.
Does that make sense?
Good,
Why
yeah.
your integral would be perfect because it's only x squared?
Yeah.
Or sorry, it's 2 over 4.
Yep.
X to the 4.
They're just powered. Okay.
All right. Now does it work there?
Or you could honestly make your function one.
Like
And
these
then
are
you can actually your
this is defining
Yeah,
for
yeah, right.
both of my
Yeah.
functions.
Yep. Say again.
So,
Sorry.
oh,
So
wait,
these like initials are
Yeah.
defining for
Yep.
both of these functions.
Yep, just starts at the top and goes down.
Okay.
Right,
So
you could
like,
redefine them in each one if you wanted to. Yep.
We'll change these both of these
Yep.
functions at the same time.
Yep, yep, because it starts at the bottom or at the top and moves its way down. And then if you could redefine it down here if you wanted to, and then
yeah,
yep.
and then like it's down here.
Okay, all right.
No.
Let's go to the next parts. That would took a little. That took a while, but that's all right. Okay, that was B. Right, use the functions that you defined above to approximate the derivatives and integrals of the function y equals cosine of x. Plot the function, derivative, and integral on the same axes, and include the legend. Delta x equals 0.01. This is you. You got this. What's that? No, it's height. So what we want to do, right? We're gonna say part B or part C, right? And so I'm gonna define my x. Well, I'm gonna just use my x's and stuff from up here. I'm gonna grab these things. I should probably call it dx, not dt. Right? 0.01 is what it said to use, right? 0.01. Use dx is equal to 0.01. Yep, dx. And then it says y equals cosine of x. D dvx, derivative, no dv. dvfx maybe is equal to our equation. What was my derivative? Look at that, it gives a little hint here. It says, oh, this is how I use my derivative. Is that what I called it? My derivative? Nope, I called it my dv.
Are we doing the next section?
Yeah, we're doing part, yeah. I think I called it my derivative. My dv, x comma y. Int fx is equal to my integ figure 3 left plot comma y hold on x. By the way, the n minus 1 thing I haven't talked about, it knows how long it is. So if I say 1 to n minus 1, it says give me all the elements except for however long it is minus 1. That's all that 1 through n to minus 1 means. And then that's x, comma, my dv dx, dvfx, and plot x, comma, mfx. Pew! Pew, it did it. It did, Kyle. We did it. We did it together. I don't want to see this output, so I'm going to put semicolons behind it. I figure disappeared again. I hate .lmx files. Give me my plot. What's the visible part? Visible, figure visible. The comment.
Trying to make a comment.
You know, I just want to see it. It keeps not plotting my figures for some reason. Oh, my fucking figure! Like, why isn't it giving me a...
Try to just run the section. There it is.
don't know why it keeps doing that. I'm gonna yell at it in a second. There we go. Okay. And then legend. Do it in order, right? Legend. We say cosine of x. Right? You do it in the order in which it came in, or that you plotted it, right? So you just put them in there just like that.
What does it
CR.
mean if my legend has different colors from?
Well, you're probably not clearing the figure each time, and so it probably has the leftover, like the first time you plotted it and the second time you plotted it. So just put a CLF after the figure, and then it'll start from scratch. Yep. No, there's some stuff. Don't get me wrong. There's weird stuff that MATLAB does. Yep. Grid on, right? And these should make sense, right? The derivative of cosine. What's the derivative of cosine? Sine. Derivative of cosine is sine or negative sine? So this is my cosines right here. And then, so negative sine is what the derivative is red. And then the integral of it should just be sine, positive sine, which is the other one. Okay? See, again, you don't need to know any of the rules of integration or like I guess rules of integration and derivatives. It just knows. You just need to know their definition. And then the brute force, calculate it for you. That's how we're able to solve differential equations in dynamics, central difference method, just by brute force. We don't have to define anything. We just use the definition of it and we brute force calculate it. But then watch what happens. Change your dt or your dx. Then my dx to 0.1. That's still okay at 0.1. We put it at 1 second. Uh-oh. Right? Your approximations aren't as good because you have too big of spaces in between. Ruh-roh, right? Right? Because they're just approximations. So you got to make this really small in order. It's because it's as it approaches 0, right? The definition is it becomes that equation. It becomes the exact answer as delta t goes to 0, or delta x in this case goes to 0. Right? So what's the other part say? Calculate the approximate derivative for all these different lengths, and plot those on the same axes with the exact solution. Ooh. Label the axes and include a legend. Also develop a quick table showing delta x versus the number. Let's try it. Let's do it.
So you just want us to plot all of the different...
For different delta x's. Just try that one on your own. Try to say, all right, do this, but do this. Maybe leave off the, what does it say to do? Plot the derivatives. Just the derivatives, not the integrals. And then do that for a bunch of different dx's.
Oh, that's fun. I know how to do that.
Yeah, I'm going to do that. Part D. Starting out at 0, 0. (1e) -5, 1e -4, 1e 3, 1e -2, 1e.
We're just plotting the derivative against x as well, or just derivative?
Yep.
Approximate, just derivative.
Yep, just the derivative. Yep. Visible on. Did it. Whew, I win.
Yeah, maybe that'll work.
What's the code? You want to see the code, Gavin?
Yeah.
There you go. There it is. Get it? Get it?
Yeah.
Here.
I
Yeah.
got it memorized.
Yeah, good, good. There it is.
What does your figure say, figure 10?
Great question, because I didn't ask it for that. I said figure 5. Maybe when you pop it out, it turns it into 10? I don't know. That's what I said. .mlx's are weird. Close all. No, maybe it's a figure visible on is what it's doing. Yeah, when you
You haven't cleared them all yet. Very good.
it's something to do with that popping out thing.
Next position 1 is invalid.
Yeah, then it pops it out of there. I don't know. Now it's figure 1. Did you get it there, Sean?
Yeah, you can use that as the random number generator. It's just every time you pop the graph out, whatever number.
Yeah, whatever number shows up on it. Yeah,
That's what it's at the end.
There. So I just looped through. I defined what my dx's were. Right. I said, whatever. I did them 1 through -5 through, or 1e -5 through 1. Right. I changed what my dx's are. I predefined those, and then I come down and I looped through all my dx's. I said let's loop through every one of them, and I'm going to make my new dx go from 0, and then dx's, and then this is dx's of I. Right. So it's going to pull one at a time what each one of these numbers are, and I'm going through 10, and then I say y equals cosine of x based off of that. Then I take the derivative using my equation, and then I plot it, right? And this last little step is a advanced maneuver, and it takes strings. Dx's are actually numbers, and it took those numbers and turned them into strings. That's what num to string means, is it takes the numbers and turned them into strings, and then it doesn't work if it's, because it's like this, you have to put it in like this, and so that little prime on my dx's flipped it on its side, so that it knew what it was doing. If that makes any sense. That's why I put the little prime. I did the transpose of it. And so then there they all are. Just an advanced maneuver there. And I guess the point there is just showing you that, right, it's just an approximation. If you change the delta t, or delta x rather, then your integration is off. It doesn't work. Right? It's not going to give you the exact answer. And as you approach infinity, or as you approach 0, you approach the real answer. Okay? We don't have to. The second part was just like, can you then look at the differences between that and the real answer? And the real answer is pretty easy to get, right? Because it's negative sign, right? That's negative sign is the real derivative. So you could do negative sign of the same number and see how off you are, and then make a table with it. Okay?
Could you share your code with us, please?
I sure can. B-dog.
Oh, never mind. I figured out.
Did you get to work,
No, I didn't.
Ciara? You need to hold on.
Yeah, I've got.
Yeah, me as well, and I'm also only showing this. Bro, the what?
What's it doing? See, I tell you, I hate .NET files. Dude, everything's right there.
Yeah, but it's just only popping up the last.
Oh. What do you call a figure like that up there? See if it. You know how I got there, like I try to figure be a visible on in the clear figures and see if that was Oh, I don't know what it's doing. Everything's right.
I'm in the same boat.
Everything's right.
Oh, I'm so silly.
I don't know what it's doing. Everything is in there.
Hang on.
What is it?
Vector
Oh yes, yes. Because it's just doing the length. One through the.
one through it makes it a vector.
Yeah,
and
yeah.
do all of them.
Turns out it was
I
doing
just
it.
got it too. I was like,
You do the same thing.
Yeah.
Yeah.
Okay.
Who's been Elliot?
syntax.
Oh my
You're
gosh,
working
I'm so
on
tired.
doing something else. Lost the second part. How many you have TS here? What's that? Yeah. It's the same file. Just down. It's just a file where I find those functions. You get it? You gotta be careful of this. When you do that for loop, it's gotta be 1 through the length of DX's. Right there. Instead of just the length of it, it just goes to the very last one.
That makes sense.
Yeah. Yep. How about you guys?
It's all some
Why are we not tracking by one? Was the reason why we're tracking by one is because of that 1,001 thing?
Yes. Yep. Because down below, you were going to. This is y of I plus 1. And if y is only 1,001 elements long, when he tries to do 1,001, this looks for 1,002, and there is no 1,002, so that would be an error. Up here, you want to go through every one of them. Like I want to go through this one, this one, this one, this one, and this one, and there is no like I plus 1 or anything like that. So
because we defined it so
Yeah.
rigorously, we do not.
yeah, and we're gonna say I'm gonna look through every one of
So
those.
yes, that's
Okay,
Yeah.
gotcha. So it's only because this one had like
It had an I plus 1.
this whole thing over here that's going
you increase it based on
to like almost infinity.
Well, it's because down here, it's going. You're trying to define an element that's I plus 1. So if the thing was 5 elements long, right? You say this is going. I'm gonna go 1 through 5. 1, 2, 3, 4, 5. So it's gonna run 5 times. When it gets to this point right here, it would try to go y of 6. There is no 6, right? There's no 6, so it can't do the 6 because it only has these 5 elements. It keeps missing. So it says now go short 1, and so then it goes through. And instead of going 6, it goes through 5, and then you'll hit that last one. And and the other one doesn't have an I plus 1, so it doesn't run into that same problem. Yep.
Right?
Yeah.
I mean, that makes sense.
Get it there. See, now it's happened, and I don't remember.
Yeah.
That's right. It is Marissa.
Yeah.
Okay, fine, that's good. It's 50-50.
You can ask him Wednesday.
And you getting it?
I did.
I got
Yeah.
it.
Kayla, you got it?
I mean, see, that's
More or less.
Well,
When it comes to the homework.
Yeah, because you go to the homework.
Makes sense.
Okay.
Like,
You got it
Right.
there?
No, I got
Your
stuck a
code.
ways back and I'm still troubleshooting my problem, so
Okay.
I'll just go back and watch the video.
Okay.
but-
You sure? All right.
All
Alright. That's all I had. We could call it there. I did assign another homework, and just to give you like a little thing, you're wondering why you're putting these pieces together. Like there's like I give you like, well, actually pull it up instead of trying to explain to you what the homework was about. Let's just.
Write this down.
Well, just to give you a little context of what's happening with this, homework 3. Okay, create a function that when given two numbers A and B, it returns a random number between those two numbers. Note that I want decimal numbers here, not just the integers. And so so you're going to create a function, right? I don't know if you want to do this as separate .m files, or you could do it with a .mlx. It's fine, but just sometimes you plot stuff, you're seeing .mlx's aren't as smooth. But basically, you give me an A and B, and you give me a random number in between those two numbers. Okay, and so we've done something similar, but it might be off a little bit on because, anyways, you can play with that a little bit, right? And it might just be a simple equation to use. Implement a function called inRange. You look to see. You give me an X location and a Y location, an X range and a Y range. X range is X min, X max. Y range is Y min, Y max. So this right here is going to be a vector with two elements, and this is going to be a vector with two elements, with has X min and X max, Y min and Y max. Okay. Then you're going to do some projectile motion stuff. You're going to make a little thing that does projectile motion. You give it the initial velocity, the initial angle, and the dt, and it gives you back the horizontal position as a function of time, vertical position as a function of time, and time. Okay, and then include a line in your program that calculates the time in which the projectile hits the ground. You did this already in original homework, but now we're going to turn it into a function. Okay, and then it calculates the maximum height along the way too, and then it'll return max. It'll return those things. Okay, and then use a for loop that then you call on that function given this for loop for a bunch of different initial velocities, and then plot a graph on each of those things for the same axis. Just like we did before, we just used our function to do some stuff. We're going to do the same thing here, use our function to create these plots. Okay, do the same thing with the while loop. Okay, and you're going to have that while loop run until something happens. On one of these things. For a particle with a velocity of 200, initial angle, random number between 0 and pi. Have the while loop repeat until the projectile falls within the box defined by X range, Y range. So you're going to use this function up above, this in range down here, to see if you're within that box. What we're building up to, by the way, is Gunner. My gunner program, right? The gunner program, you gave it the initial velocity and the initial angle, then it launched it, and you wanted to see if you hit that box. Well, that's what this is doing, right? And I think this last while loop is you do a bunch of shots. Like you're not going to control it. You're just going to let it go until it goes until it hits the box. Eventually, it'll hit the box. But, anyways, that's what this is about. If you're wondering. Okay. And break. That's all I have.